Thanks a lot for putting the paper on the program. What I want to talk about today is, okay, the slides are not moving, sorry. Right. No, it works, okay. So what I want to talk about today is the following, what is shown on this chart here, which is the slow-moving secular dynamics in real interest rates. Here's one example of a real interest rate series. It's an ex-ante real interest rate where I took 5-year treasury yields and I subtracted 5-year Michigan survey expected inflation. And you can see, the familiar pattern, the rise in the 1970s into the 1980s, and then a 4-decade decline until very recently of these real interest rates. And so what I'm going to talk about today is trying to understand these slow-moving dynamics. I'm not going to have a lot to say about these shorter-run wiggles around those longer-term trends. Now, the kind of standard explanation or the standard, place where people look for an explanation why real interest rates had these slow-moving changes is variation in the so-called natural rate of interest. Here's one example of an estimate of this natural interest. It's an often used series by Laubach and Williams. You can download it from the New York Fed website. It's shown here as the red line. And as you can see, these series, they seem to share some trend, but there's also a lot left unexplained, even for these slow-moving changes. And so that's what I'm interested in explaining. And the story I'm going to tell you today is going to have 3 elements. There's going to be a setting where agents basically try to figure out long-term inflation, the inflation in the long run. They're going to learn about long-run inflation from realized inflation experiences, and they're not going to listen to the words of central bankers. So basically, expectations are tied to historical experiences that people have, and the consequence of this will be that long-term expectations change slowly as a function of these experiences that people accumulate. The second element will be that monetary policy doesn't like it, or monetary policy makers don't like it when these expectations that people have deviate from where policymakers would like these expectations to be. And if there's a deviation, they're going to lean against this deviation with the usual tools of monetary policy with the federal funds rate. And the consequence of this will be you have these slow-moving expectations, monetary policymakers leaning against it, and you're going to get persistent effects on real interest rates. And the third point that's a bit more subtle is that in that role that I have in mind, agents are going to perceive these real interest rate effects of that monetary policy induce as basically permanent. And as a consequence, it's going to be not only short-term real rates that are going to move with long-term inflation expectations, it's going to be the whole term structure of real interest rates that are going to move around. All right, and so I'm going to show this to you in several steps. So first, I want to go back into a little bit of evidence, updating some work that I had done earlier with Ulrike Marmendy on how people form inflation expectations. Then a brief look at a simple model that now looks at how the macroeconomy looks like when people form inflation expectations in this way and how monetary policy plays a role there. And then the empirical evidence on real interest rate dynamics. I'm probably going to focus on the US only, but the paper also has international evidence from Germany, UK, and Japan. All right, so let's first look at expectations formation and a brief recap of the empirical evidence on this. So in my early work with Ulrike, when we studied inflation expectations formation, we started at the following point where we basically said, well, when people try to forecast inflation, they broadly have 2 things in mind. They're trying to figure out what's the long-term mean, and they're going to try to figure out what's the shorter-term persistence. And so we capture this by assuming that people have in their mind an AR1 law of motion, where this AR1 law of motion has some parameters, A and rho, that they're trying to figure out from the data that they experience, right? And then we basically have people do least squares learning, but least squares learning with a twist that the gain in this least squares learning is age dependent, which basically means when people get older and they have more data accumulated in their lifetimes, they react less to a new inflation surprise. So a young person reacts a lot, an old person reacts less to a given inflation surprise. Yeah? And as a consequence, you get cross-cohort differences in inflation expectations. And so here's an overview of the evidence on this. all the way up to the dashed line. This was our original sample in our earlier paper. And to the right of the dashed line is now something I added now, the out of sample evidence. And the dots here in this chart show you the inflation expectations over a 1-year horizon of different age groups in the Michigan survey of consumers. Black is older people, red is middle-aged people, and blue is young people. And sorry, I got it wrong. Black is young, red is middle-aged, and blue is the older people. And everything is shown relative to the cross-sectional mean. So when a group shows up above 0, above a high level, this means they have above average inflation expectations. If they show up below, they have below average inflation expectations. And if you now look through this over time, you see that in the 50s and 60s, these age groups were quite similar in their inflation expectations. But then as the inflation rates start going up in the 1970s, you see this wedge opening up between young and old. By 1981, young people had about 3 percentage points higher inflation expectations than older people. Then it took almost 2 decades for this gap to close. And in the 2000s, it was actually reverted. So then older people had higher inflation expectations than younger people. And all of this is sort of broadly consistent with this notion that memory here plays a role of these experiences. For example, most recently, older people had the memory of the 70s, younger people didn't. And this helps explain why these inflation expectations differ. And the lines on that chart, so the dots are the actual data. The lines on the chart show you basically the fit from this least squares learning model with this age-dependent gain that we set up. Yeah? And so one important thing now is that in that gain specification down there, you can see there's a parameter theta, and that parameter theta basically controls how fast people forget data within their own lifetimes. And that's a key parameter for how fast these inflation expectations are moving. And in the Michigan survey, we estimated this parameter to be about 3. And what's going to be important now for what I'm going to do now is that I'm going to fix in what I do now this parameter at that value, which basically pins down how fast these inflation expectations are moving. And I'm not going to vary this now to fit real interest rates better, right? So basically, I'm going to keep that parameter tied down from the micro data. All right, so this was the review of the evidence. And now I'm going to simplify now a little bit to go and think about macro questions. The first thing is I'm going to forget now about cross-cohort heterogeneity. And instead, I'm just going to focus on, if people form inflation expectations in this way, what are the implications for the dynamics of the average belief that people have? So averaging across age groups at every point in time. Yeah? Okay, and I'm basically going to give that average belief to a representative agent, if you want. Yeah? And the second simplification I'm going to make is I'm going to ignore shorter run dynamics. I'm just going to focus on long-term inflation expectations, which I'm going to label pi tilde here. Yeah? So I'm going to focus on long-term inflation expectations. I'm also going to focus just on slow-moving secular dynamics, and I'm not going to have much to say about shorter run dynamics. All right. Now, about these long-term inflation expectations and the dynamics of the average belief, there's something that we already showed in our earlier paper, Ulrike and I, that in this case, for the average belief, the dynamics actually become now very simple, and particularly simple for the dynamics of the belief about long-run inflation. It becomes a simple constant gain updating scheme, where basically you take the previous forecast of long-run inflation and you just form a weighted average with the most realized inflation rate. But the important thing is this phi there is pinned down by this theta parameter that we estimated in the microdata. And so again, as I said earlier, I'm going to keep this fixed at the microdata implied value, which is 1.6% quarterly. Okay, so this is now going to be my expectations dynamics that I'm going to use in what I'm going to look at now. All right, and so the first thing I do is I stick this kind of expectations formation mechanism into a simple new Keynesian model. And so here I just repeat this updating scheme that I just mentioned, right? This constant gain updating. And then I add a Phillips curve where inflation rates to expected inflation in the usual way. An Euler equation. I'm going to use a discounted Euler equation here, which you can motivate in various ways, either with cognitive discounting as Gabex, or McKay, Nakamura, and Steinson have an incomplete market story for this. The reason why I need this is I'm going to have real interest rates, long-term real interest rates move around a lot. And if I didn't have a discounted Euler equation, I would basically run into the same problem as the forward guidance puzzle, that there would be extremely strong output responses. And so I'm using kind of the usual tool for addressing this, this problem there. And the final piece is a monetary policy rule, where monetary policymakers now are leaning against these long-term inflation expectations if they deviate from the target that the policymaker has in mind, right? And so let me show you how this now plays out if you do some numeric analysis with this model. So in this chart, focus first on the black dashed line. These are some cost push shocks that I'm feeding into the model for a number of periods. You can think of the first 20 periods here, where this black dashed line is high, as kind of the 1970s. You get a bunch of cost push shocks. And then these cost push shocks, they kind of go away. There are no more shocks. But now the question is, what happens to the endogenous variables in the model? So the first thing, blue line, you can see inflation is high, but it actually goes up a little bit more than just what's induced by the cost push shocks directly. Why does it go up more? Well, the answer is the yellow line, because every inflation realization now gets built into inflation expectations, which through the Phillips curve again generate a little bit more inflation, right? And so long-term inflation expectations go up. That's the yellow line. And now the Fed doesn't like it when these inflation expectations go up, so they're going to raise interest rates, and as a consequence, the real rate relative to subjective inflation expectations, which is the blue line here, goes up along with these long-term inflation expectations. Yeah? And so that's the key thing now I'm going to look at for in the data. Is it the case that we can explain slow-moving dynamics of real interest rates with these experience-based long-term inflation expectations? Do they have sort of the same, slow-moving dynamics over time? Okay, and so here's the data I'm going to look at. There's a bunch of real interest rates I'm going to use, an ex-post real rate that's shown here as the black dashed line. There's a real rate ex ante that I'm using relative to professional forecasters' expectations. That's a blue line. A real rate relative to households' inflation expectations. That's a red line. And then the experience-based long-term inflation expectation series to explain this, which is the black line here in this chart, the solid black line. Also going to use different horizons for real rates. So, 1 year, 5 year, 30 year, here shown relative to household inflation expectations. Okay, now about the econometrics, what I'm kind of interested in is doing something like this, right? Putting a real rate on the left-hand side, could be either a realized real rate or an ex-ante real rate, and then finding the relationship of this real rate to, on the right-hand side, some measure of long-term inflation expectations. Now, this is not going to be easy because, these series are highly persistent. There could be unit roots in these series, but we are also not sure whether they are unit roots. There could be co-integration, but maybe not. So it's not entirely clear. And so I'm going to use an approach that basically allows me to do inference with unknown order of integration that goes back to Viceira, Shin, and Smith. And so the way this works, briefly, is you basically estimate an error correction model. You put not the level, but the first differenced real interest rates on the left-hand side. And then basically you estimate, the extent to which there's error correction. And there are two parameters here that are relevant. You can see there's an A and a beta. So the X variable here would contain, the X vector would contain these long-term inflation expectations, or a proxy for that. And the question is, do they affect real interest rates? So if they affect real interest rates, this would mean when real interest rates are unusually high relative to beta times the long-term inflation expectations, then we should see a correction in real rates. That's basically what this equation is going to look for. But for that to happen, you need both the A and the beta to be non-zero, right? And so this is kind of the key thing that the Viceira, Shin, and Smith test then tests for, that both of these are not zero. Right? Okay, so let me show you one table, and the rest I'm going to show you all in figures. But the way this works is focus on a bottom panel B. These are the error correction model estimates. I basically have long-term inflation expectations that come out of this experience-based updating as an explanatory variable, and then also the Laubach-Williams natural rate of interest. And in column 2, you can see I put both of these in, and the long-term inflation expectations get a coefficient of about 1.5, which means that 1 percentage point higher long-term inflation expectation translates into about 1.5 percentage points higher real interest rate. And the coefficient on a natural rate is very close to 1, which is kind of sensible. And at the bottom, you see the PSS test, this Pesar-Shin-Smith test, that basically tests, rejects the null hypothesis that there is no long-term relationship between long-term inflation expectations and real rate. So you basically want a rejection there in that line. And then in the third column, I'm now basically, well, the coefficient on a natural rate should kind of be 1. So let me also explore a more parsimonious specification where I directly subtract the natural rate from the empirically observed real rate. And then you can think of this as a constraint specification, and then just use one explanatory variable, these long-term inflation expectations. And the coefficient doesn't change much, it's still around 1.5, as you can see. Okay, and then I do this for a bunch of different real interest rates now on the left-hand side. The one I just showed you is the one up there in blue, coefficient of about 1.5. In red now is using 1-year real interest rates. In green is 7 years forward. Just a little remark, I don't have 7 years forward inflation expectations to compute the real rate. So I've subtracted the Michigan, so the 5-year expectations as sort of a proxy, right? There's no 7-year forward inflation expectation there. The model I have also implies that the coefficients, when you put realized real rates on the left-hand side, the coefficient should be getting higher as you go to longer, longer tenors. And so that's also consistent with this here. So the previous chart was with realized real rates. This one here is now with ex ante real rates. And so for this one, the model predicts that all of these should have the same coefficient. And that's also what I find. The coefficients are all about 1.5. So again, 1.5 percentage point higher long-term inflation expectation translates into about 1.5 percentage points now shift basically in the whole term structure of real rates, not just at the short end, but also at the long end. This is how it looks like in terms of fit. So if you now take the estimated values from the error correction model for how ex ante subjective real rates relative to household inflation expectations, and you ask, how much does this now add in addition to what's explained by the natural rate of interest alone, then you get the blue line. So this is now taking together the explanatory power of the natural rate and these long-term inflation expectations. And the black dashed line is what we're trying to explain. This is the actually observed ex ante real rate. And you can see the blue line gets a whole lot closer to matching these long-term dynamics of the observed real rates than the natural rate of interest alone. Okay, I also do this with professional forecaster expectations. They only have 1 year forecasts. I get a coefficient of around 1, slightly lower than when I use household inflation expectations, but roughly speaking, in the same ballpark. A brief look at international evidence. So when I do the same thing for Germany, I get slightly higher coefficient. These are realized real rates on that I'm explaining here. Same pattern as in the US. The coefficients get bigger as I go to longer tenors. In terms of explanatory power in Germany, it looks like this. Again, inflation expectations help a lot to explain what's going on relative to just a natural rate series alone. This is the UK, again, with exposed realized real rates. Again, a pattern of increasing coefficients as you go to longer tenors. Here's how it helps explain the series in terms of fitted values. And then finally, the last bit is Japan. In Japan is kind of the only odd one out where for longer tenors, I get a little bit lower coefficient. And then you can also see the blue line here is a lot closer to the actually observed realized real rates than the natural rate of interest alone in Japan. The paper has a few more things to say about other things that we know are empirically going on with real and nominal rates. So for example, there's a puzzle that short-term nominal rates move a lot with long-term real rates. That's also something that happens in my model here, because both of these have a common component that's moving with these long-term inflation expectations. Long-term yields are sensitive to macro announcements. That happens in my model here too, at least to the extent that the macro announcement is having news about inflation, because news about inflation leads to an update of long-term inflation expectations, which then feeds into monetary policy and expected short-term rates and so forth. And then finally, there's evidence that the secular decline in long-term yields is actually correlated in FOMC announcement dates. And this was a paper by Hillenbrand. And most recently, a paper by Alam shows that among those FOMC announcement dates, it's actually those where the FOMC announcement is preceded by macro announcements on the same day or the day before. And again, it's, yield moves basically concentrated on macro announcement days. And that's also what would happen in my model, because, for example, in this time period since 1981, agents would be repeatedly surprised when new inflation news comes out, then inflation is lower than what they had expected, and they would update their expectations again and again in the same direction. Yeah. And then yields would move in the same direction as well. Okay, so let me conclude here. What I've been arguing is that through this leaning against inflation experiences channel, monetary policy has a substantial and a very persistent effect on real rates. And so, there can be secular changes in real rates that are not variation in the natural rate. But I also briefly want to comment on something you might be wondering about, which is in this model that I have here, central bankers can do nothing with words, basically, right? There's no other way of influencing inflation expectations other than through realized inflation. And the way I see this is a model of kind of normal times, but I don't have fiscal regime changes or any other drastic changes in the model. And so I don't see this as a contradiction to, Sargent's argument, for example, that when you have a drastic regime change, you can reset expectations, right? So I don't think of this as being kind of opposite to the view of the world I have here. Yeah, let me stop here. Yeah, thanks.